Hello, we are recording our second set of video lessons for our Summer 1 2018 Earth Science class. Here we're going to do a big synopsis of stratovolcano versus shield volcano. Don't worry, I'll walk closer to the board when necessary to allow this to focus. We're going to begin with the stratovolcano. There's some glare in this room, it's kind of hard to avoid it, so we're beginning with the stratovolcano. Stratovolcano, as you see in my crude drawing here, has your classic volcano shape. It's a cone shape. We expect to find a crater at the top. So let's start going through our main bullets here. What is true about shield volcanoes? They're going to have a high viscosity magma. Remember that viscosity refers to resistance to flow. A high viscosity magma does not flow very easily. This means that it will trap gases, lead to a dangerous buildup of gas pressure in the magma chamber, eventually leading to a pyroclastic eruption. What else is true? High silica content. Si is just short for silica. Remember those silicate minerals that like to link together and make single chains and double chains and sheets? A high silica content helps to add to that high viscosity. What else is true? Felsic to intermediate magma types. Also a low temperature magma. Yes, a low temperature magma. What kind of eruptions is it going to lead to? Pyroclastic eruptions. These are the ones that are explosive and dangerous. So these are the ones you might see on the news where you see this big, huge, scary looking gray cloud racing down the mountain, and that is your pyroclastic cloud. These are the kind of eruptions that are very deadly. These are the kind of eruptions where your volcanologists need to do the best they can to try to predict when they think that volcano might erupt, because all you can do is try to evacuate people and get them out of the way beforehand. Examples would be Mount St. Helens, Mount Rainier, Vesuvius, Krakatoa. Oh, something else we need to say about our stratovolcanoes is they have a high volatile content. Remember, the volatiles are the volcanic gases, things like sulfur dioxide, hydrogen sulfide, water vapor, and carbon dioxide gas. There are other volatiles besides those four, but those are the only four that we will need to know for our upcoming exam. So by the way, just very recently, last week maybe, week before, there was a bad pyroclastic eruption in, I think it was Guatemala, and there were some villages real close to the mountain, and there were a number of people that were killed. They were not able to get out of the way in time. All right, so again, we're still on our stratovolcano here. That is pointy like a cone. Okay, so let's come over here and talk about the plate boundaries that that produce our stratovolcanoes. So, two basic types of plate boundaries here that produce stratovolcanoes. Ocean to continent subduction zones, like the Pacific Northwest, Oregon, Washington, Northern California, or the Andes Mountains on the west coast of South America. But also our ocean to ocean subduction zones, such as Indonesia, or the Aleutian Islands, or the Mariana Islands. So it is at these plate boundaries that we tend to find our stratovolcanoes and our really scary eruptions. All right, and if you're wondering what kind of eruptions we have at a continent-to-continent collision, I will remind you that there is no volcanism at a continent-to-continent collision, so there are no eruptions there. No active volcanoes in the Himalayas. Okay, well, we're going to move over here now. Let's back up a little bit. I think the light glare maybe isn't as bad. Now we're going to tackle the shield volcanoes. Our drawing up there shows that, well, they look like a warrior's shield, very gentle slopes. So what's true about shield volcanoes? Low viscosity magma. That magma flows easier. This means gases escape easier. This means that the magma can leave the volcano pretty easily, and it does so in many different fissure eruptions. And the big island of Hawaii, Kilauea volcano. So the Pu'uwa'u vent has been erupting continuously since 1983 and is erupting currently. And then there are new vents and fissures that have opened up. If you haven't been paying attention, golly, what, couple months now, I think? We have had just so much activity out of the Kilauea volcano. Nobody's been killed because this is a different kind of volcano. The eruptions are much more calm, but it has wiped out houses and neighborhoods. So other things we could say about the shield volcano: high temperature magma, low silica content. Both of these things tend to give it low viscosity. It's also a mafic magma. We also have a low volatile content. All of this, including the low viscosity, helps to lead to these effusive eruptions. Effusive eruptions, which are mostly lava flows. They could come out of, multiple vents at one time. In the case of Kilauea, they could come out from fissure eruptions. Yes, you've seen on the news, if you've been watching this, you do see some ash clouds from Kilauea here recently, but trust me, that is not a pyroclastic eruption. So these are calm, gentle eruptions. Honestly, we can say that nobody has to die from a shield volcano. Okay, so where do we find them?